In this part of 2.3, we're going to talk about what graphs of functions look like. So you have to ask yourself, what would the graph of a function have to look like? If we can't have any repeating x values, how is that going to change what our graph looks like? So let's take a look at that. We have what's called a vertical line test. Now, a vertical line test can tell us whether or not a graph represents a function. Now, this is very important up here. If every vertical line intersects a graph only once, then the graph represents a function. Now let's see here. If I were to have a vertical line where they have it drawn here on the graph, it only goes through the graph once. So that means that it's a function. Well, what about over here? And here, and here, and here, and here. Anywhere I put a vertical line, it only passes through the graph once, which means that it's a function. Now let's take a look at the one on the right here. Well, the one we drew passes through it twice. So at any point, if it passes through it twice, I know that it's not a function. If I draw a line here, it passes through twice, or here twice, here twice. It doesn't matter. Wherever I draw that line, if it passes through twice, then it's not a function. Let's take a look at another graph real quick. What if I had something that looks like this? Let's say I have my graph here, there's my x, y, and then let's say I have a graph that looks like this guy right here. Well, if I draw a vertical line through the graph here, it only passes through once, so it's a function, right? Not quite. What if I draw it here? Well, that vertical line goes through it 3 times. So if it goes through it more than once, it's not a function, so this would not be a function. No. Alright, let's do a couple examples. In this example, we have to find our domain, our range, as well as tell whether or not this is a function. Well, if we remember back to geometry, what we have here this time is an array. It has an endpoint, and then it goes on forever and ever in this direction. That arrow tells me it goes on forever and ever to infinity and beyond to hang out with Buzz Lightyear. Well, let's first start out with finding our domain. That's our x values. If I look here, it starts where this dot is, and it looks like it's where x equals -5. Remember, these are my x values. This is my x-axis. The horizontal one's my x-axis. And this right here is -5. So my graph starts at -5 for my x values. Now this graph goes on forever and ever and ever in this direction. Now are my values getting bigger or smaller as I go in that direction? I go to -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, and so on. They're getting positive. They're going up. They're getting bigger. So my domain will be greater than -5. So x is greater than or equal to -5. We got to include this point here because it starts at -5. -5 is part of this array that we have here. Next, our range. Let's see if you can get this one on your own. So feel free to pause the video and try it. See if you can get it. We're talking about our y values now. Well, my y value here at the start is -2. And I have all my values that are larger. So if I think, okay, well, it won't go below this line. It's only going above. Well, that means it's above -2, so y is greater than or equal to -2.